Assalamu alaikum. Welcome to the electrical power transmission course. Today I am going to explain how to select the economical voltage for the transmission line. First, I am going to define what is an economical transmission voltage. The transmission voltage for which the cost of conductors, cost of insulators, transformers, switchgear and other terminal apparatus is minimum is called economical transmission voltage. In the previous lectures, it has been proved that if the transmission voltage is increased, the volume of conductor material required is reduced. This decreases the expenditure on the conductor material. Therefore, it may appear advisable to use the highest possible transmission voltage in order to reduce the expenditure on conductors to a minimum. However, it may be remembered that as the transmission voltage is increased, the cost of insulating the conductors, cost of transformers, switchgear and other terminal apparatus also increases. Therefore, for every transmission line, there is optimum or economical transmission voltage beyond which there is nothing to be gained in the matter of economy. It may be noted that the transmission voltage has following relationship between different equipment. Transformer's cost is directly proportional to the transmission voltage. Switchgear cost is directly proportional to the transmission voltage. Lightning arrestor cost is directly proportional to the transmission voltage. Insulation and supports cost is directly proportional to the transmission voltage. The conductor cost is inversely proportional to the transmission voltage. Now the method of finding the economical transmission voltage is discussed as below. Power to be transmitted, generation voltage and length of the transmission lines are assumed to be known. Then choose a standard transmission voltage and find all the cost of transformers, switchgear equipment, supporting towers and conductor. The sum of all above cost gives the total cost of transmission for the voltage considered. Now similar calculations are made for other transmission voltages. Then a curve is drawn for the total cost of transmission against voltage as shown in the figure. It may be noted from the figure that the lowest point P on the curve gives the economical transmission voltage. Thus, in the present case, OA is the optimum transmission voltage. To further clarify this concept, consider the graph which shows an arbitrary case in which total cost of transmission system is taken in $1 million for different high voltages. It can be noticed that for this case up to 500 kV, the total cost goes on decreasing, which make the transmission system economical. However, when voltage is further enhanced to 765, the total cost goes on increasing due to increased cost of transformers, towers and protection equipment. Therefore, for this case, 500 kV is the economical option for high voltage transmission. However, it may be noted that this method of finding the economical transmission voltage is rarely used in practice, as different cost cannot be determined with fair degree of accuracy. Therefore, the present day trend is to follow certain empirical formula for finding the economical transmission voltage. According to American practice, the economical voltage between lines in a three-phase AC system is given by V is equal to 5.5 multiplied with square root into 0.62 into length plus 3P upon 150, where V is the line voltage in kV, P is the maximum kilowatt per phase to be delivered to single circuit, L is the distance of transmission line in kilometer. It may be noted here that in the above formula, power to be transmitted and distance of transmission line have been taken into account. It is because both these factors influence the economical voltage of a transmission line. If the distance of transmission line is increased, the cost of the terminal apparatus will be decreased, resulting in higher economical transmission voltage. Furthermore, if the power to be transmitted is large generating and transforming units can be employed. This reduces the cost per kilowatt of the terminal station equipment. Now I am going to discuss an interesting way to select the economical transmission voltage. A rough basis of determining the most economical transmission voltage is to use 650 volt per kilometer of transmission line. For example, if the transmission line is 100 km, then the most economical transmission voltage will be 100 into 650, approximately equal to 66 kV. By using this simple rule, the most economical transmission voltage for 50 km will be 33 kV, and for 200 km it will become 132 kV, and so on. It may be noted that this rough basis of determining the economical transmission voltage is very important, and this technique is very useful in solving the MCQs based test for electrical jobs. Let me test how much you are clear about this topic. Just look at the MCQs question given here related to this topic. The question asks, if the length of the transmission line is 200 km, then what will be the most economical transmission voltage on rough basis? It gives 4 options. Can you guess the right answer? If you are clear in this topic, then definitely the correct answer will be option C, which says that for a length of 200 km, the most economical transmission voltage will become 132 kV. Therefore, these smart tips help a lot in solving all these questions, especially in MCQs type test. That's all for today's lecture. I hope you enjoyed this lecture. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.